Hi, this is Mrs McTaggart. In this video we're going to be looking at the third level topic of angles in a triangle. Our learning intention today is to be able to calculate missing angles within any type of triangle, and there's loads of different types of triangles we will be looking at. We'll be looking at scalene, right angled, isosceles and equilateral triangles. So what I've got here is a random triangle drawn. Now the actual name for this triangle, because it has no special properties like no equal sides, is a scalene triangle. Just to remind you of that word if you haven't heard it before, and it is spelled like this. So this is a scalene triangle. All the sides are different lengths. Now what I'm going to aim to do here is prove that all these angles in the triangle add up to a certain number. If this was in class, I would get out protractors and I would be able to use software to animate these. It's a wee bit difficult to do in the video, so I'm going to try my best to do it similar to what I would do in class. So I'm going to take a little shot of each of these corners here, and I'm going to reposition these two, so like that, and you can see they're almost touching. And then my third triangle, if I take a little image of that one and pivot it around, you'll see that that probably, with a little bit of playing, is going to slot right down into that one and match up. So on my next screen I've actually got it on a wee bit better. I've got this bit here. So you can see that these three triangles, the red, the blue and the green, all cut up and rotated, create this thing here, which is called a straight line. Now a straight line, we should already know from previous knowledge, is 180 degrees. Now another way to prove that these angles add to 180 would be to pull on a protractor, which I can't actually do on this video, I'm afraid, but I have already measured these two angles when I drew them out, and they were 45 and 25, so at the moment that counts for 70 degrees, which would make this last angle up here 180, take away 70, which would be 110 degrees. Okay, so it doesn't matter what triangle I draw, whichever triangle I draw, all three corners or all three angles on the triangle will always make 180. And a lot of times when we talk about angles, we say the magic sum is like always taken away from 180, and here it is again. So let's get to some examples, and this is where I would start copying down the little sentence first of all, that the angles in a triangle always add to 180 degrees. So my first example is a scalene triangle, and we want to know what this angle is here that's marked X. So you basically just have to add up what you've got and subtract from 180. So my first sum would be 125 plus 15 degrees, which gives me 140 degrees. And then you'll do 180, take away 140 degrees, which leaves you with 40. So the marked angle is 40 degrees. Okay, so that's for a scalene triangle where I've given you two angles already. So example 2 is a right angle triangle, and we know that denoted by the little red square down the corner, which means that we know that this angle here is 90 degrees. So again, to get the missing angle, we do 90 plus 18, which is 108, and then we do 180, take away 108. Remember, you can use a variety of methods here. You can do a physical sum like I'm doing just now, or you can do mentally. If you're doing mentally, I tend to count up and go, right, well, 2 degrees takes me up to 110, which means I've got another 70 to go, so 72. Or we could do the good old subtraction method, so exchange the 8 into 7, bring over the 1 to make it 10. 10 take away 8 is 2, 7 take away 0 is 7, and 1 take away 1 is 0. So the missing angle here is 72 degrees. Now, there is another little trick actually. If this right angle is 90, it means that these two angles here must also make 90. So a shortcut, instead of doing two sums, could just be to do 90 take away 18, which is 72. But not a lot of people spot that one. It's not hugely important. Right, before I go into my next couple of examples, I'm going to just remind you of the other two types of triangles we talk about in maths. So we already knew a scalene was the one that had three completely different sides, so all different lengths was a scalene. Now we're going to look at some isosceles triangles, but it's worth also mentioning an equilateral while I'm here as well. An equilateral triangle has three identical sides. That means it's got three identical angles. So to get all the angles in an equilateral triangle, I have to do 180 divided by 3, which is 60. So that's maybe a little trivia fact that it's worth remembering, that all the angles in an equilateral triangle are 60. But in an isosceles triangle, these two little black lines on the side mean that these two sides are the exact same length. Now, if they are the exact same length, it means you've got symmetry running down the middle of this triangle. And it means that this angle here and this angle here match. So these two angles are identical, and we're going to use that fact in all the next examples. So let's look at example 3. This is an isosceles triangle, which we know by the lines marked to show that these are equal sides. Do not ever assume a triangle is isosceles. Do not ever assume a triangle is right angled. Unless it's got these two lines or a little square, you cannot assume anything, okay? So we already know that this has got symmetry down the middle. So this angle and this angle match, making it really simple to get angle A. Angle A is 70 degrees because I didn't have to do any work in there. So to get angle B, we do 70 plus 70 is 140. And then the angle at the top would be 180, take away 140, which is 40 degrees. So angle B is 40 degrees up the top. So that's that style. That's an easy isosceles one. Let's have a look at this one. So it's not always letters we use. Sometimes there's nothing at all there for the marked angles. Sometimes they're named using letters. For example, I could put some letters here and call this A, B, C. So the one that I've marked with the star would be called either BAC or CAB, as long as in the middle, as long as A is in the middle. So let's write that that is angle CAB, and we're going to work out that one first. Now, this is an isosceles triangle, but kind of spun on its side. So these two match, so both of these angles are 25 degrees. And then the one with the dot would be named, let's go with ABC, put B in the middle, because B is the angle we're after. And to get that, we're going to do 25 plus 25 is 50. And then we're going to do 180, take away 50 is 130 degrees. So that is 130 degrees for the angle with the dot, or as I've changed it to letters, angle ABC. Okay, let's look at example 5. So this is a tricky isosceles triangle because in all the other ones so far, I've given you one of the matching ones. This one, I've given you the obtuse angle at the top instead. So the way to do this one is, well, we have to do a takeaway first. So we do 180 take away 150, which leaves us with 30. And that means that angle A and B make 30 together. So 30 divided by 2 would give you what A and B are, which would make them both 15 degrees. So angle A equals angle B, and they both equal 15 degrees. And example 6, we're going to look at one more. And again, I've put in symbols, and I'm kind of tempted to change it to letters again. The first one we're going to get is the star. Now, the star is on a straight line with 114. So these two need to make 180. So to get the star, I'm doing 180, take away 114, which is 66 degrees. Now, that also means that the square is matching to the star. So that is also 66 degrees. And then what I'm going to do is I'm going to add them together. So 66 add 66 is 132 degrees. So the angle at the top is 180, take away 132, which is 48 degrees. So the one at the top is the star, which is 48 degrees. So this is a point in the video where you would hit pause and try some of these on your own and work out the missing angles. And then when you unpause, you'll see that the answers are all there. I hope this has helped. Thanks very much for watching.